Hey guys, so in the last lecture, we have seen vapor dominated uh, thermal power system, geothermal power system. So today we will see liquid dominated, that is wet steam geothermal systems. So as the name suggests, that it is dominated with the liquid and not the vapor. So, in liquid dominated geothermal power plants are run when the geothermal fluid is the mixture of water and steam. So, if this is the geothermal fluid, then it can run in the liquid. In the liquid dominated geothermal reservoir, hot water with various degree of salinity. This salinity at a wide range of temperatures available. Due to high pressure, the water does not boils at high temperature and it remains in the liquid state. So, when water comes to the surface, the pressure is reduced and rapid boiling then occurs, and the liquid water flashes into the mixture of hot water and steam. So, the dry steam can be separated and used to generate electricity. So, this steam can be separated and can be used to generate electricity, and the remaining hot water can be utilized for process heating purposes. So, liquid dominated power plants can be classified in three categories mainly based on temperature. There is high temperature system, that is if it is greater than 180 degrees Celsius. Then comes moderate temperature system if it is between 90 to 180 degrees Celsius. Then there is third, uh, low temperature system, that is less than 150 less than 150 degrees Celsius. So here this is liquid dominated flash steam system, this total flow system. Here in medium you can have liquid dominated binary cycle system, and low you can have hot water system. So we'll see all the three system based on different temperature ranges having similar construction but with a few difference. So we will see. We'll start with liquid dominated flashed flashed steam system. So in this high temperature liquid dominated system, water is above 180 degrees Celsius. So however, due to high pressure, the water does not boils at a high temperature. It remains in liquid state. But as I told before, that when water comes to the surface, the pressure is reduced and rapid boiling then occurs, and the liquid water flashes into mixture of hot water and steam. So a general layout will be geothermal fluid, that is steam plus hot water, will go to suppose hot water. So this is suppose hot water is required. So this hot water will move from a flash steam separator. There is flash steam separator. So here this the hot water is converted into the steam. It is separated and is passed to the steam turbine, and then it is passed to generator. So not then due to the turbine rotation, it is coupled with generator, so it will generate electricity, and the steam is phased out from the turbine. So production well delivers a mixture of hot water and steam to the flash separator. The steam and water are separated. So here the steam and water are separated. The steam is supplied to the steam turbine, which is coupled with this electric generator. So the discharge of the steam turbine is passes through a direct contact type condenser. The part of condensate is circulated through the cooling tower. Water coming from the condenser and cooling tower is re-injected to re-injection wells, and the remaining highly saline water, that is called brine, is from separator can be used for direct thermal applications and then re-injected to the ground. So this is the whole concept of liquid flash geothermal power plant. So we will again uh, draw this whole power plant. So all the same components are there. So so from here, suppose geothermal fluid is taken and it is passed through flash separator. This is flash separator, and this is passed through a turbine. So then it is passed through a condenser, and this turbine is coupled with a generator, and after passing through this condenser is coupled with a cooling tower where the water is cooled. So this is a cooling tower, and then from this condenser it is injected back to the ground, and uh, there is a water circulation here. There is cold water circulation from condenser to the cooling tower, and so on. So that is so this is the whole geothermal power plant. So now we will see a similar second system, that is, if the temperature is little bit low, it is around 90 to 180 degrees Celsius. So that is liquid dominated. It is liquid dominated binary cycle system. So this is a binary cycle system. So flash steam system is not suitable for geothermal fluid having low or moderate temperature, because this temperature is not enough for efficient flash steam production. Also, there is need of bulky flash separator when geothermal fluid having higher content of dissolved minerals. Others, other, other components in working fluids faces the corrosion problem. So, in this binary cycle, has two cycles with a common heat exchanger. So, the geothermal fluid, so that is geothermal fluid, that is steam plus hot water, extracted by a production well. So, it is extracted by a production well, circulates only through heat exchanger. So, it circulates only through heat exchanger, and heat exchanger, the geothermal fluids gives up this geothermal fluid gives up heat to low boiling point working fluid, normally volatile organic fluids such as isobutane, freon, propane, ammonia, etc. So here is the working fluid, and then it moves through the vapor driven turbine and electricity is generated. So there is the heat is being passed to another com- another another component, that is freon, propane, or ammonia. So liquid dominated binary cycle geothermal power plants consist of two heat exchanger, turbine, surface condenser, cooling tower, and electric generator. Hot water or brine from the underground reservoir circulated through a primary heat exchanger. So let's draw again to understand. So suppose this is the ground, and suppose from here the hot water is taken and it is uh, re-injected back to the ground, and from here, through heat exchanger, the heat has been taken from this hot water. So the heat has been taken from this hot water to the another component, that is, suppose isobutane, ammonia, or anything else. So then this is passed through a turbine and it will provide electricity because it is connected to generator. Then this turbine is then again passed. Then this turbine is then this isobutane is passed through another heat exchanger. So this is passed through an heat exchanger, and it is it is then it is then cooled. uh, th- this this is then cooled with the help of condenser. So this is then cooled with the help of condenser and cooling tower. So this is connected to a cooling tower and so on. So this is the concept. So here there is a change, that here we are using a heat exchanger instead of flash flash steam separator. And also, so and also this is, the temperature is a little bit low. So the liquid isobutane turns into superheated vapor, and this superheated vapor is expanded in the turbine. So the exhaust vapor from the turbine is cooled into a regenerative heat exchanger and then condensed in the condenser. The condensed liquid isobutane is returned to primary heat exchanger by the way of regenerative heat exchanger. So main advantages of binary fluid systems are that is there is no problem of corrosion or scaling in the working fluid circuit. Low temperature geothermal fluid can be utilized for power generation. Geothermal fluid is returned to the earth, and there is no environmental power associated with the hydrogen sulfide emission, and in some cases higher conversion efficiencies than flash steam systems is found. So this is somewhat more useful than the flash steam separator power plant. Then the third power plant is the liquid dominated hot water system. So liquid dominated hot water system. So in this hot water system, so this this has very low temperature of hot water. So liquid dominated reservoirs are most numerous hydrothermal resources in the world. So it can provide direct heat for residential, commercial, industrial, agricultural buildings, including greenhouses and animal shelters. And for food and industrial processes, hot water can be utilized for refrigeration and air conditioning. So the energy of hot water resource can be utilized in a hybrid system consists of a geothermal conventional system. In this system, hot water resource is used to preheat feed water and for air for combustion. So the liquid dominated water system, the hot water is brought to the surface where the heat exchanger transfers the heat to another fluid such as liquid or air, which distributes the heat at required places. And the geothermal fluid can be directly used if the salt and solid content is low. So the geothermal fluid is re-injected into ground after extraction of heat. Hot water system is very economical when geothermal site situated near a heat utilization site. So it does not appear to be feasible at present to transport hot water for distances greater than 24 kilometers. This is partly because the cost of pumping, piping, etc. partly loses the heat with increase in the distance. So this is generally a simple system that you are taking the hot water and passing it to another hot air or water, whichever, with the help of an heat exchanger. This is the simple concept, and you are using that air or water. So this is, if the temperature is very low, you have no option than by only using that heat directly for the purpose, rather than converting it to the electricity. So this is, so now we'll discuss the last, that is total flow system. So this is for the high temperature liquid, that is greater than 180 degrees Celsius. So total flow system, geothermal power plant. The entire geothermal fluid brine is passed through special turbines. Unlike steam is separated from the brine in flash system, or heat is extracted from the brine in the binary system. So the geothermal fluid passes from a wellhead into the turbine, and from the turbine to the condenser. So the total wellhead output is expanded in the turbine and discharged in the condenser. So let me draw it again. So suppose from here geothermal fluid, the whole brine is passed to the turbine, and here there is a generator, and then this whole brine solution is then passed to the condenser, and there is a cooling tower here. So this condenser and cooling tower will help in cooling the water, and in the similar way, uh, then it is back re-injected to the ground. So this is the concept. So the geothermal fluid passes from wellhead to turbine, and from turbine to the condenser, and the total wellhead output is expanded in the turbine and discharged into condenser. Therefore, it is called a total flow concept. So there is no flash steam separator. Therefore, it is called total flow concept. So radial impact turbine, helical screw expanded turbine, or bladeless turbine are used in a total flow system geothermal power plant. So this is the main concept of total flow system. So here directly the brine is passed with the help of pump into the turbine, and then the power is generated. So this is the whole concept of total flow system. So now we have seen the vapor dominated and liquid dominated. So I will just point out few of the differences between them. So suppose this is vapor dominated system, this is liquid dominated system, and these are the differences, suppose, which we are going to point out. So first is simplicity. So first is simplicity. So simplicity due to directly availability of the dry stream. So directly the dry stream is available. So this is a simple, more simple. Here there is complex due to separation of dry stream from the mixture of steam plus water. So this system is little bit complex. Minerals dissolved. So here this, as it is steam, so the minerals are less, where it is in the form of water and steam, so minerals are more. Corrosion. So here there is less corrosion because it's steam. Here there is more corrosion because it is a form of water. So there are different components. Then environment. So it's less because it is a dry stream. So here there is an impact of environment because more, because of higher content of dissolved minerals in the geothermal fluid. Then power density. So power density. So here the power density is higher. Here it is higher due to higher temperature of geothermal fluid. Here it is less due to low temperature of geothermal fluid. So these are the differences between vapor dominated and liquid dominated. As you can see, the vapor dominated is more convenient than the liquid dominated system. So these are the main differences between the two systems. So from the next lecture we will see few geopressure resources and etc. So thank you very much.